As a final thought for our lesson 5.2, I'd like to have a conversation with you about a very interesting integral. It's actually the integral of the sine of x. Now, remember, the sine of x is that up and down periodic graph, and it has an interesting area, specifically if we look from just 0 to pi. And that area you're going to discover is 2. Now, what we're going to do is we're going to look in the book on page 264 and continue this conversation, but eventually you're going to do a little exit ticket out of this. So it'd be helpful for you to have your book open and know that I'm going to go over some of the initial examples, but you will finish the remaining for a small grade. All right, now if you look on page 264, you'll see there in that box that they do indeed tell you that the integral of the sine of x from 0 to pi is 2. But let's make sure you understand where that is and just specifically what that is referring to. It does show you in the book, but it can be helpful to see it on your own calculator or take a look at mine. I brought it along. Here's the sine of x. It is that common graph. But now that we're in calculus, we're going to be kind of noticing some new things about this graph, specifically from 0 to pi. We're going to notice that this area, that is this area under one bump, is actually just equal to 2. Now we're going to take that as a given, and we're going to use that to find some other areas that are connected to this space or this interval from 0 to pi, but indeed would be new. Are you ready? You can see them in your book. The first one there is the integral of the sine of x from pi to 2 pi. Now, if you have your calculator still on, it's still the same sine wave, but I want to make sure that you're looking at it at the right spot. And indeed, you should be looking from pi to 2 pi. So now we're talking about this space. Now, it's still the area of one of these bumps, isn't it? So what's going to be different? That's right, it's going to be negative. So it's still 2, but of course it's negative 2 because it's now under the x-axis. See how this works? We're going to take what we're given and we're going to use that to come up with some new areas. How about the area from 0 to 2 pi? Okay, now this time we're taking the full sweep from 0 all the way over to 2 pi. So we're taking the positive with the negative, aren't we? Technically, we would end up with 2 and negative 2. Yes, they cancel out to be 0. Yes, we end up with an integral or an area equal to 0. I'm going to do one more with you. It's going to be number 3. And this time it's the integral from 0 to pi over 2. Again, if you have this on your calculator, you can continue to look at it. Some people do like to draw sketches, especially when it comes time to do this for a little grade. You do have to have knowledge of where pi over 2 is. Pi over 2 is going to be halfway. That's a little hint, isn't it? Halfway in this first bump. So we're looking at just this piece. Well, of course, if the whole bump is equal to 2, and we've only traveled halfway through that interval, then it would reason to think that this one is going to be half of 2, which is 1. And indeed it is. Now, for the problems that you're going to do, I would say that you may not have 100% certainty of the answer. You might have 99% certainty, but there's a piece to this exit where you're trying to just make a conjecture. You're trying to make an educated observation. And I do know that a couple of them, when it's all said and done, especially near the end, that students sometimes are like, I don't know. And so what you're going to do is you're going to give us your best thought. I also want to say that you're not permitted to find these answers using other techniques. What other techniques could there be? Maybe using something on your calculator, maybe like a program or a special button. I would just say kindly that you want to experience the thought process behind these. You want to look at the graph, you want to see where that bump has gone, and then you want to take what you know, which is that the area is 2, and figure out how you can connect that to your new area. All right, so we're going to make a little exit ticket out of Um, the remaining questions, I believe it's 4 through 9. If you count carefully, there are 4, 5, 6, 7, 8, 9. That's 6 problems, and it's only worth 5 points. So I even give you one that you can get wrong and it won't be counted against you. Okay, so the first one here is number 4. It's the integral of 2 plus sine from 0 to pi. Now, type that in your calculator, but I want you to know that I'm going to give you a little hint on this one. I would have given it to you if we had been in class anyway. Want to make sure that you're getting off to the right start. Okay, 0 to pi of this graph. Okay, definitely we're talking about this region right here, which does include the top part, the bump as we're calling it, but it also includes this region down here, which kind of looks like a rectangle, doesn't it? So a little tricky here for the first problem, but you're going to take what you know and you're going to connect that to that rectangle that I showed you, and you're ready to go. All right, so problems 4 through 9 as an exit ticket.